Let us talk about functions. Remember that we start defining a set, and then we talked about relations, and then we talked about functions at the beginning of our course. So as you remember, functions are just relations with some added conditions. I'm going to officially define a function here. Definition of a function. Very good. A function like f from the very first set that we call the domain, from set X to the second set that we call the codomain, to set Y, is a relation from X, which we call the domain again, to Y, which we call codomain. It's not yet the range, we call it the codomain. The range has a specific definition that satisfies the following conditions. First of all, every element in X is related to some elements in Y. And number two, no element in X is related to more than one element in Y. What's the meaning of that? What you learned from pre-calculus, from algebra, it passes a vertical line test. So this guy is nothing but the vertical line test, the second condition. Very good. Usually write it this way. We say that his function f maps set X to set Y. So function f maps set X to set Y. Sometimes we represent it this way: X arrow Y, and put the function here. So as you remember, your function f acts like a machine. You have some input values like X values, and you have some output values. So input and some output values. X values go inside, and you get some output values like f of X. So this X is small x, and you get some output values like f of X. Now we're going to define the range of the function. So we have domain, we have codomain. Now we're going to define the range of the function. Range of function f for the image of X under function f is defined as the set of all y values in the codomain such that y is equal to f of x for some x in the domain x. So again, guys, this is the range of the function elements from the codomain such that there are some x values that connect those x values to y's. Remember that the range is a subset of codomain. So range of f is the subset of codomain. Very good. We have another definition as well. For an element like y belongs to the codomain y, the inverse image of y is defined as follows. Is defined as the set of all x values in the domain such that f of x is equal to that y. So this guy is called the inverse image of y. Important definitions: the range of a function and the inverse image of an element. So let's go over a couple of examples to feel more comfortable about what's going on here. I'm going to write down these two definitions up here. So when we are going over the example, we have that as a reference. So we have a function f, maps x into y. The range of the function f is the collection of all of your y values such that your y is equal to f of x for some x in x. And the inverse image of y is the set of all x values such that y is equal to f of x and y belongs to y. Okay, let's take a look at this example. Suppose we have the following sets. The very first set, x, includes ABC. This is my set x with A, B, C. And I have the second set, y, which includes 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to define a function like this. My function takes A to 2. That's my function. My function takes B to 4. My function takes C to 2. Okay. So as you can see, this is just y, the codomain. It's a larger set that include the range. It might be equal to range, but depends on the definition of the function. Okay, so now we're going to answer these questions. What is the domain? What is the codomain? What is the range? Is C an inverse image of 2? Is B an inverse image of 3? Find the inverse image of 2, 4, and 1. Okay, we're going to answer these questions. So what's the domain of this function? The domain is a set including A, B, C. So D, or the domain is A, B, C, a set including these 3 elements. Codomain is this larger set. So codomain CD is the set including 1, 2, 3, 4. What is the range? The range of the function just includes 2 and 4, 2 elements, 2 members. Okay, this is the domain. Now, is C an inverse image of 2? How do they define the inverse image? They should be connected by F somehow. C is the inverse image of 2? Yes, of course, we can see a connection between them. Yes, because F of C is equal to 2. Is B an inverse image of 3? The answer is no. B is connected to 4. F of B is equal to 4, not 3. And now it says, hey, find the inverse image of 2, 4, and 1. Well, the inverse image of inverse image of 2, inverse image of 2 is a set including A and C. The inverse image of 4 is set including B. An inverse image of 1. 1 is not connected to any set. It's going to be empty set.